Today we're diving into the important tools of calculus. The first derivative test. This test helps us understand how a function behaves, where it reaches its high points and low points, also known as the local maximum and minima. Let's start with a quick review. The derivative test tells us how much the function changes, whether it's going up, down, or staying flat.
The first derivative test involves three main steps. The first step is to find the derivative of the function. The second step is to determine the critical points, and how you do that is by setting the derivative equal to 0 or checking where it's undefined. The third step is to analyze the sign of the derivative on intervals around the critical points. If the derivative changes from positive to negative, we have a local maximum. If it changes from negative to positive, we have a local minimum. If the sign doesn't change, there's no extreme, just a flat point.
So here's our first example problem. First, you start out by finding the derivative of the function, which comes out to be this in this particular problem. The second step is finding the critical points by setting the derivative of the function equal to 0. So here, after that, you factor to find the critical points, which in this case comes out as x equals 1 and x equals 3, as you can see through this process. The third step of this problem is testing the intervals. So basically, you pick a point. Right here, I picked 0, 2, and 4 to find out if they're positive, which means increasing, and negative if they're decreasing. So here, f of 0 comes out to be 9, which is positive, which means it's increasing. Here, f of 2 comes out to be negative 3, which is negative and decreasing. On this one, f of 4, it comes out as 9, which is also positive and increasing. So at x equals 1, the function changes from increasing to decreasing, which comes out as our local maximum. And then at x equals 3, it changes from decreasing to increasing, which comes out as our local minimum.
So for practice problem number 2, our equation is x to the 4th minus 4x to the 3rd. So we find the derivative of that, and we get 4x to the 3rd minus 12x squared. Next, we're going to find our critical points. So we set our derivative equal to 0. Then we factor out the x and find our critical points at x equals 3 and x equals 0. Our step 3 is to check the intervals. And for x equals 1, we got negative 8. And for x equals 4, we got 64. Step 4 is to find the maxima and minima. And at x equals 0, it stays negative, so that means no maximum and minima, but it is a point of inflection. And at x equals 3, it goes from negative to positive, so it's a local minima at x equals 3.
All right, well, let's wrap it up. The first derivative test is very powerful because it helps us find where the function reaches its peaks and its valleys. And additional help would be, on your own, you can try to summarize the steps of the first derivative test, then make your own function and practice as much as you can. I hope this video helps a lot, and y'all do well on your test.